Okay, we're glad you've joined us today. Today we have a special guest, Johannes Weber. Many of you who've been around IPv6 for the past decade or so probably have read things that he's written or seen presentations that he's given on IPv6. Johannes is a network security consultant for SVA, Systems Vertrieb Alexander GmbH in Germany. He has a master's degree in IT security and he specializes in IPv6 security. He excels in implementing next generation firewalls, DNS, IPv6, and helps customers. He teaches classes on IPv6 and DNS and VPN, DNSSEC, NTP, Wireshark, and delves into the details of enterprise-grade firewalls like Palo Alto Networks, Fortinet, Juniper, and other manufacturers. He has a really great blog, which we're going to link in our show notes. And so, Johannes, welcome to the IPv6 Buzz.
Yeah, thanks for having me. I'm glad to be here.
Thank you so much. So today we're going to be talking about IPv6 advantages. And so, Johannes, you've put together a list of IPv6 advantages. I'm curious what's on your list and kind of why you've pulled together this list.
Yeah, so when I'm at the customers, I always talk about IPv6 at least once an hour, whether or not the customer wants to hear it. So this is how I am, yeah. So I see that almost all people are biased towards IPv4. So I almost hear sentences like, oh, the addresses are too long and they are unhandy for IPv6. Or we have enough IPv4 addresses. Or something like, I will wait until I retire because I don't want to learn this new stuff. Or this one, which is, you have been telling us for 20 years now that it's coming, but it isn't. So to my mind, the only argument that anyone knows is that it solves the IPv4 address problem. So it's always like we have to use it, though we don't want to. So in fact, I could argue against all those prejudices, like this time it's for real. So yes, we have telling this for 20 years, but this time it's real. Or I could say something like, look at the stats. We are like 50% plus worldwide IPv6 usage. So come on. Or I could predict a dark future, something like when you're not starting with IPv6, all your home office users won't be able to connect to your remote access VPN someday, or something like this because of carrier grade NAT and so on. But I decided to do it a little bit different because I want to point out the advantages of using IPv6 compared to IPv4. I want the network admins to know that there are more advantages than just the solving of the IPv4 address problem. So it turns out that IPv4 has many obstacles as well, even more than IPv6. The difference is that we are used to use IPv4. So in the end, to my mind, it's a matter of habit. So currently, everyone is used to work with IPv4. So we are used to navigate around those obstacles we have with IPv4. So I want to present an IPv6 that has advantages so that the network admins by themselves want to know more about it, want to use it. So one of my sentences at the customers is, or when I'm giving these IPv6 classes is, please overcome your prejudices. Start using IPv6 and enjoy its advantages. By the way, I don't know why so many network people are afraid of IPv6. Because we're living in the IT world, so everything is updating all the time. So for whatever reason, network admins don't want to use this new stuff. So I don't know why. Maybe it's because they don't know the advantages. Okay, so let's dig in. A picture is worth 1,000 words. So I've made a small network sketch comparing network configurations or network designs between legacy IP, IPv4. I like that phrase, legacy IP, and IPv6. I've called it, I love IPv6 addressing. So on my blog, you can find it. That's a little network sketch. However, let's talk about it. So I've pointed out some advantages for IPv6 compared to legacy IP. So let's dig into. So one of the first things is different subnet masks thing. Variable length subnet masking. So we all know for IPv4, we have this many different sizes when it comes to subnets. So we have /24s, that's the obvious one, but we have you name it, 26, 27, 28. We have /30s for point-to-point links. We have /22s for guest Wi-Fi's and so on. So think about it. It's really complicated. Whenever you first started using those subnet masks, so we have in school, we have in an IT school, we have classes just dealing with this IPv4 subnetting. We have calculation, we have the network address, the broadcast address. This whole process is error prone. So we even need third-party tools like network calculators to get this stuff done. So, and the most commonly used IPAM, which is Excel, is not aware of IPv4 subnetting. So when I'm at the customers, we have IPAM tools, I know, but Excel is still a big thing for IP address management. So I think this is a burden for IPv4. So think about it. We are used to it, but it's not good at all.
Yeah, with IPv4, you have to know binary arithmetic. Like they say, there's 1-0 people in this world who understand binary and those who don't or something. But with IPv6, you're just using a single hex digit to represent some value. And yeah, so with IPv6, I think there's : 1 types of people in this world know IPv6 because that 0, : 0, or : is a valid interface identifier. And then : 1 would be the second usable address in the host portion of the address. Yeah. But I mean, Excel is pretty good compared to, manually bespoke configuring Bind9 zone files with VI.
So I want to point out that for IPv6, we don't have this concept of variable length subnet masking anymore. So we have this fixed prefix boundary /64s. So we only have to look at the first 4 hex stats and we are done. We exactly know what's the network part, what is the host ID. We don't have this concept at all anymore. So we don't need network calculators anymore to ask what is the next available /64. We can simply look at the numbers and we can choose the next one. So for IPv4, if you have an address plan and you're asking what's the next available /26, that is free. So you have to think what other networks are within my bubble. So it's a hard one. So I think, or routing tables, it's so much easier to look at routing tables or routing tables if you have this fixed boundary of a /64 compared to IPv4, where you have so many different subnet masks. So along with this is the slash notation. So for IPv4, you had it in your last show, the slash notation versus the dotted notation for the subnet mask. For IPv4, we have 245, 245, 245, which is a /24. For IPv6, we only have this slash notation. So this is another advantage for your day-to-day business because you don't have to deal with this calculation vice versa between the dotted notation and the slash notation. What's the subnet mask for a /27, Scott?
240.
So it's a little hard to think about all this subnet mask for IPv4. So for IPv6, we just don't need it anymore. So this is what I want to point out here.
I think as we move into a domain where IPv6 is more widely deployed, what I'm hoping that a lot of the folks that we work with, the sort of message that they carry away is that it's okay to have space in reserve. It's okay to have lots of prefixes that you aren't numbering into right away. At least initially, in many cases, trying to keep things organized around nibble boundaries in order to, as you say, like when you're looking at a routing table or when you're looking at any sort of accounting of like what prefixes you have configured in the network, if those are consistently sized prefixes along nibble boundaries, it's very, very simple to sort of see the network administratively and from a configuration perspective. This is really with a full acknowledgement that at some point in the future, there may be a lot more using of IPv6 prefixes that don't fall along neat nibble boundaries that result in larger routing tables and having to sort of carve up the space. I would say that there's no reason to do that prematurely because of the space that's available that you can number into and avoid that outcome, but recognizing that that's certainly what's happened with IPv4 and far enough into the future of IPv6, it may actually be what happens with IPv6 as well. But at least initially, as you point out that, those CIDR boundaries, and then if we kind of stick to the nibble boundary, there's There's a lot of space that we're keeping in reserve, and there's a lot of like just sort of simple organization of the network that provides for us.
You got me. It's a .224. Is the Sorry, I got to give up my CCIE number if I mess that up.
Okay, gotcha. Yeah, one more thing that I like about this concept that we have this fixed boundary is that we can look at an IPv6 address and we immediately know to which network it belongs to. So for IPv4, if you have an IPv4 address in your firewall log, for example, let's say a 192.168.1.235. So the question is, to which layer 3 subnet does this IPv4 address belong? So the answer is you can't answer it because you have to know the subnet mask. So maybe it's out of a /30, maybe it's out of a /16, you don't know. So if you have all these junk variable length subnet masked all over your network and you see a simple IP address, then you have to look it up from which layer 3 interface is it coming. So some customers have the first network as the default gateway, some have the last. So if you're looking at the root interfaces, the firewall interfaces, you have to calculate or what's the subnet length here, where, and so on and so on. So with IPv6, you can see the complete address. You don't have to know the size of the prefix because it's a /64. You can immediately spot from which network this IPv6 address comes from. So I think this is really an advantage for my day-to-day business because when I'm looking at log files, that's what I'm doing sometimes. Yeah, you can easily spot it.
Yeah, and I think you make a good point because with IPv4, we have to know the host address, we have to know the network and the subnet mask to put it into context. With IPv6, you just need to know the prefix. You assume a /64 in almost all networks. And the interface identifier, even if it's static or dynamic, you almost don't care what the last 4 hextets are. It's either, going to be used with or resolved with DNS or it's dynamic and you don't care and it might change.
So next one, I have to increase my network size. So small example, I have a DMZ, which is a /29 for IPv4. So that is, it gives me 6 usable IP addresses. One is the default gateway. So I have 5 usable IPv4 addresses for my servers. But in the meantime, I have to install the 6th server into this DMZ. So what I'm going to do? This is a bad situation because you either have to increase the subnet size. This is only working if the subnet be after the ones that used or before the ones that used is free, which normally is not the case. And if so, you have to touch every single host on this network. So normally this won't happen. So what customers are creative, what are they doing? They add secondary IP addresses to their routing infrastructure. So within the same VLAN or the sub interface, you have 2 different rooted layer 3 networks, which is a bad design again. So for IPv6, we simply don't have this problem anymore. Anyone should know we have to the power of 64 host addresses per network segment, so we won't ever run out of addresses per subnet. So this concept of I have to increase my network size simply is eliminated completely. So again, this is a big advantage when using IPv6.
Yeah, all the nodes on a v4 network have to be in agreement about the subnet mask.
Exactly.
Or rely upon proxy ARP to stitch things together unbeknownst to some people.
Just to point one thing out, don't get confused. Roots are summarized. So for roots, it's perfectly fine to have other subnet sizes other than /64. So the /64 only for layer 3 subnets, but a root perfectly is like a /48 or so. So within your routing table, you still have variable length, but not on the router interface itself. Small exception is probably a point-to-point link where you might have a /127 or 126, however, but the normal case is the /64.
I think I've run across that 127 or 126 prefix configured on point-to-point links. That seems to be more of a legacy configuration these days. I think there are quite a few carriers that adopted it back in the day when, early IPv6 timeframe, 2008, 2009, when there was an actual security risk associated with it, at least for a very short period of time. And now I think maybe there's a little bit of confusion out there with newer adopters of IPv6 where they're not sure if they have to adopt that standard. And our advice is generally that this is not something that is still impactful from a security perspective, and you're perfectly safe to use a /64. Reserve a /64 for your point-to-point link, and configure a /64 for your point-to-point link. And from an administrative standpoint, it just seems like that's much simpler and easier to track. You probably get away from the possible unforced error of like the idea that it's like, well, if I do the same thing I'm doing in IPv4, where let's say I have a /24 and I'm allocating /31s or 32s out of that /24 for point-to-point links, I'll try to do the same thing in IPv6 and start carving out /126s or 127s from a single /64, which very, very bad idea. But you might think that that's kosher to do because that's something that you're used to doing in IPv4. So
IPv4 thinking again.
Yeah, exactly. And so the general advice we're trying to give is like, well, let's just focus on using a /64, configuring a /64 on a point-to-point link.
One more, I call it like obstacle, one more stumbling block for IPv4 is the number of subnets and the number of prefixes you have to remember when you are a network IT administrator. So think about it. For IPv4, every single enterprise I know uses all three RFC 1980 address spaces. Yeah, you know them, 10/8 and so on. So every single enterprise I work with here in the German region, they are most commonly mid-sized, they are an own autonomous system, so they have multiple public IPv4 allocations, again, each with different network sizes. So we have three different subnet mask sizes for this private allocations, RFC 1980 address space, plus let's say three more public IPv4 allocations, let's say 122, 123, and 124. So when I'm asking a network administrator, can you tell me your IPv4 network prefixes? And he is like, yes, we have this, and we have this, and in the DMC we're using this, and then we have this public, and we have this public, and we have this public. So in the end, I have like, it's like 4 to 5 to 6 different prefixes. So what do we have with IPv6? With IPv6, when you're an autonomous system, you have your one and only address prefix. You have your PI space, which is probably a /32, for example. So in the RIPE NCC region, we can get a /29 if we want, without any further questions. So let's just stick on a /32. So we have this one and only prefix. And for this prefix, note that a /32, for /32, only the first 2 hextets are filled. All the other 6 hextets are completely zero. So we have something like 2001 db8, the documentational prefix, for example. So to be honest, it's really not that bad, not that hard to remember 2 hextets like 2001 db8. So I've been working with different IPv6 prefixes all day. So if you read the same prefix like 10, 20 times once a day, after 1 week, you definitely know this prefix. It's not that hard compared to so many different prefixes you're using for IPv4. So come on, guys, it's not that hard. Yeah, it's definitely an advantage.
Yeah, those 4 digits on your keyboard are going to be, those keys are going to be very polished from typing in that very often. Yeah,
I think there's this IPv6 numpad where you have IPv6 buddy, they call it. Yeah, where you have these hexadecimal digits. Yeah.
I'm old enough to have gotten one of those given to me at one of the V6 conferences that I went to back in the day. I don't remember.
Yeah, we used to hand those out at the IPv6 conferences.
I have one as well. I ordered one back then. I never used it, to be honest, but it's always funny to show it because you have this double colon button, which is very nice. Yeah. So additionally, now you have your one and only IPv6 prefix, but it's not historically grown. But you can shape the future because you can create your own subnet structure within this single prefix. So in the end, you have one prefix and you have your own network structure within it. whether it follows VLAN IDs or whether it follows /48 for each site. I've heard there are books written about IPv6 address assignment. So get one and read through it, and you will see it's much easier if you're working with it on a daily basis. You can see it's really not that hard compared to IPv4. You can even optionally, you can put in some metadata within the subnet IDs or even within the host IDs and so on and so on. The next thing I hear sometimes is, talking about those unhandy IPv6 addresses. They are so long. I already told you this. No, they are not. You can abbreviate them. And they count from 0 to 9, from A to F. It's not intuitive. So think about it. I say that IPv4 counting is not intuitive as well, because you're counting from 0 to 255. This is not intuitive. If you're in the decimal, in the base 10 space, you're counting from 0 to 9 or from 0 to 99 or even 999. However, you're not counting from 0 to 255. But this is exactly what the guys that are telling me that IPv6 addresses are complicated are saying, well, IPv4 is uncomplicated. I say it's not. You're simply used to it. So that's the case. So in the end, you will use DNS anyway. So I have never seen one single person typing square bracket and then the hexadecimal numbers within their browser. Okay, for network guys, yes, you have to do your network and host configuration. There you should use numbers, got it. But in the end, you will use DNS anyway. So get rid of this thinking that IPv6 are complicated. They are not. It's just a matter of habit.
Yeah, it's a fair point. And it's something that extends, as you say, into the host ID, into the prefix. And the reality is, as you correctly point out, well, as network folks, maybe we have a slight advantage in that we're more used to just staring at prefixes, whether they're V4 and V6. And, I to this day, I can still remember, the first 3 octets of the prefix that housed the DNS servers for the first ISP I worked for. And I'll take those numbers to my grave, because it's just, programmed. You just program yourself by, as you say, staring at it enough times through the course of the day. But it's no different with IPv6. And the impediment of just being more comfortable with hexadecimal character representation, that's quickly overcome. But there are definitely times when you're talking to somebody who's new to it, you get the sense that that's something for them that's more of a struggle, trying to get them over that hump. It's really just to say, you just spend some time with it and you'll get comfortable with it, and you'll see that, as Johannes is pointing out, it can be as streamlined and as straightforward and even more straightforward than what you're dealing with in IPv4.
With IPv6 addressing, you gain this simplicity, and with the simplicity, you gain ease of operations. Through ease of operations, there's less human error and therefore increased reliability. Also, with complexity comes risk. With complexity comes the edges that security adversaries like to exploit. And with simplicity comes ease of security and less edges that attackers can exploit.
Keep it stupid simple.
Just a brief pause to ask, did you know Packet Pushers has a job board? Whether you're looking to find or fill your next great IT infrastructure role, the Packet Pushers job board is the place to go. It's easy to post, easy to browse, and easy to apply. So whether you've got IT talent or you're looking for IT talent, visit jobs.packetpushers.net and get to work. That's jobs.packetpushers.net.
Next point. Now, I have the enterprise glasses on, and we have site-to-site VPN to partners. Guess what? What IPv4 address spaces are my partners using? Well, they are using the same RC1980 addresses. So what do we have to do? We have to use NATs at our routers or firewalls. So most VPNs I'm seeing in my daily business, we are using source NAT and destination NAT. So destination NAT at our firewall, VPN connection, source NAT at the partner's firewall, because you want to have the routing back without injecting your own network prefixes into the partner's routing table. So you still have to find a free IPv4 address block to do this. It's not even that you don't have to find any free address blocks. Even for NAT, you have to use them. So this is, I think it's really a hard burden, because we have NAT solves the address problem, got it, but NAT involves or NAT creates many more problems. So we even have many NAT techniques to overcome these problems, like NAT traversal. Or we have application layer gateways for zip, or we have something like stun or turn and so on and so on. So you've named all this stuff. Oh, one more example. This is out of my daily business. Which IP addresses are in my logs? So when I'm at the client side and I want to connect to a server at the partner, but I'm doing at least one destination NAT and one source NAT in traversal, I have completely different IPv4 addresses in my logs than my partner has in his server logs. If we also do in port address translation, there's almost everything exchanged except the destination port. However, it's really complicated to find the same session on both sides because you have to replace so many IP addresses that are dynamic. So probably if you don't know the state in the meantime, it's really hard. So in case of troubleshooting such issues, so to be honest, normally we are troubleshooting the VPN itself because IPsec is not working as we wanted between different firewall vendors and so on. However, if the VPN is working and something at the application layer is not working as we want it to be, we have to troubleshoot it at layer 3, for example, to see the session initiation and so on. So for security incidents, your incident response team won't be happy if so many NATs are in the path of your routing. So guess what? For IPv6, we don't have this problem anymore because my partner is using his own PI space, for example. So we can just use routing. So yes, there's probably some other problems because you have to route the partner's PI space within your internal network. So that's another discussion. But at first, it's way easier to use it that way compared to IPv4, where we have this NAT burden in this place.
Yeah, you make a great point that by all organizations using globally unique addresses that don't overlap, your information in your security information event management system becomes more effective because the address that's represented there is the true address, not a translated address, and there's no overlap. And so with IPv6, you get this reduction in anonymity. The anonymity exists when there is multiple layers of NAT, and it's difficult to do tracebacks or peel all that back when it's the mega proxy problem. So reputation filtering with IPv4 degrades, but reputation filtering improves with IPv6.
And then we have this NAT thing again when we want to reach the internet. So, of course, we don't have this end-to-end connectivity with IPv4, but we use NAT and port address translation when we're going to the internet. So everyone knows this. So for IPv6 global unicast addresses, we don't need this NAT anymore. So we have this end-to-end connectivity again. We don't need this NAT techniques like NAT traversal, application layer gateways, and so on. So it's way easier. You have a completely component. You can get rid of this component because it's working without it. So just to state it again, NAT is not a security feature, neither for IPv4 nor for IPv6. So addressable is not the same as accessible. Yes, your clients are globally unique addressable. But for sure, every single enterprise I know has a firewall that at least blocks incoming connections. So they are addressable, but they are not accessible, even for our home router. So in Germany, we have the home router. It's called Fritzbox. We're using it everywhere. Even this home router has a built-in firewall that blocks incoming connections per default. So I know there are other brands out there that probably don't do it, but at least from my perspective, this is not a security problem at all that we don't have NAT anymore. So I have a blog post talking about NAT is not a security feature for IPv4. So if you want to join the discussion, feel free to find it. So it gets even worse with IPv4 when we come to CGNAT. So this is exactly what I'm facing. I'm here with my local ISP. I have a fiber to the home connection, which has native IPv6, but not native IPv4 anymore. I'm sitting behind a carrier-grade NAT. So I'm NATed twice. So again, I have this NAT traversal stuff. I have troubleshooting issues. As an enterprise, I need a static destination NAT for coming into my own servers. For my home lab, just putting on the glasses for my home lab, what have I done the last decades? I have made something called port forwardings for IPv4. So I have this one and only public WAN IPv4 address, and I can do a port forwarding for port 443 to my Raspberry Pi, for example. So with IPv6, I have a couple of advantages here again, because I'm not stuck on one single HTTPS server, because I can only have one port forwarding for one public IPv4 address on port 443. Now with IPv6, I can have multiple servers within my home lab, for example, all reachable about with port 443. And now since that I am sitting behind an ISP that only has carrier grade NAT for IPv4, I cannot reach my IPv4 home lab at all. I have to use IPv6, which luckily is not a problem because every major mobile phone provider in Germany has IPv6 embedded. So it works. So even again for IPv6 brings me back the reachability of everything, for example, in my home lab. So because, for example, we don't have NAT and PAT anymore, but global addressable addresses, which is quite good, which is an advantage from IPv6, clearly. Let's almost come to an end. I have one more. This is probably not a big deal, but let's just talk a little bit about it. This is about split DNS or different DNS views. Split DNS for in an enterprise environment, you have your DMZ where you have private IPv4 addresses for a server, and you want that internal clients that rely on a DNS name, you want this DNS, the A record, you want the private IP address returned to the user because he shall access the server over the private internet, private connection. But for if this user is on the untrusted network with the same host name, you want to point to the public IPv4 addresses, which then gets nutted. So you have split DNS configuration. For IPv6, you don't need this anymore because your DMZ is global addressable, and it's regardless whether the user is inside your network or outside the network, the single DNS name points to the same single IPv6 address. So you have this split DNS. You don't have it anymore. You don't even have these 3 U-turn NAT configurations anymore. So I think one of the questions for some Palo Alto network certifications, always this 3-zone U-turn NAT. You don't have this stuff anymore just because of this global addressable thing.
Getting away from using NAT with IPv6, it has a performance improvement potential as well, because we're not either backhauling traffic through a NAT, traffic is able to flow more directly.
Coming to the end with my list of IPv6 advantages, I would say that the concerns of using hexadecimal IPv6 addresses remain a prejudice. So if you work with IPv6, you will lose the fear of it. And you will see that it has advantages that are way easier in your day-to-day business compared to IPv4. You just have to start with it.
So Johannes, we covered a lot of ground, a lot of IPv6 advantages that it's really wonderful to hear, and we're definitely in alignment on what those are. Is there anything that we haven't asked you that you'd like to address before we sort of wrap things up?
My recommendation for people that are not yet into IPv6, let's talk about this for a second, is my recommendation is simply start using IPv6. So it doesn't have to be the entire company network. Just to be honest, you won't add IPv6 to your whole company network within the next years. So just start with a small lab or the guest Wi-Fi or with one DMZ just to gain some experience. So of course you have to route your PI space to your router and to your firewall and into your DMZ, but then start adding it into your VPN endpoints and to your mail servers and to your HTTPS servers, to your proxies. By doing this, you will gain some experience, and this makes it easy for admins to get used to IPv6 addresses within routing, within firewall rules, within application logs, and so on. And again, this reduces the fear of IPv6. So I will promise you, you will love it.
If you need any help on, how to configure IPv6 on your VPN, Johannes has written some tremendous articles over the years on all the popular next generation firewalls and how to configure remote access VPNs as well as site-to-site VPNs with different vendors on each end. And if you read the stuff Johannes has contributed to the body of work on IPv6 security, even dating back to his master's thesis on IPv6 security, through all the articles he's written, I really appreciate all that you've done. And I've learned a lot from you over the years by reading your articles on everything from DHCP v6. And I remember you wrote the article about the Cisco firewall with the 14 and 18-bit DUID issues with registration, and how to send an NTP server and DHCP and network miner. And then you've given lots of presentations at SharkFest, probably like 2018 through 2023. You've given a lot of talks about deep dives into IPv6 and packets. And I remember years ago, you gave a really great talk at Troopers 18 on dynamic addresses and VPNs. And so definitely, I think the VPN is a great place to start with an IPv6 deployment to get some experience. You can work on one profile in your VPN that's only accessible by IT people. You don't have to do maybe the production VPN profile that's accessed by everyone in the enterprise. You can start small, and a VPN is a great way to get started because it's at the internet edge, and it's something you can test without having to bring IPv6 very deep into the infrastructure, right?
Yeah, thanks for that, Scott.
Yeah. So thank you for all of your contributions in the past, and we look forward to the things you're working on and future things you write. So as we wrap things up here, Johannes, how do people, follow you or keep track of things that you're working on? How do people find you on the internet?
Yeah, so I'm still using Twitter or X. You can find me with my handle WeberNetz. Yeah, on the show notes you'll find the link as well. So I'm using LinkedIn, of course, so you can find me there. And yes, I have this blog, so feel free to follow it. You can follow it via email or via RSS feed and whatever you like. I just want to point out that here in Germany, I'm giving 2 to 3 day courses for IPv6. So if anyone is interested in this, feel free to reach me out. And I want to point out that on my blog, I have something called the Ultimate PCAP. This is a single PCAP for Wireshark, obviously, which has about 19 plus protocols in it. So you can use this single PCAP as a single point of source for protocol examples. So there's lots of IPv6 stuff in there, of course, all the well-known stuff like ICMPv6, neighbor discovery, DHCPv6, relay, and so on. But I also have upper layer examples like HTTP, TLS, SMTP, OSPF, version 3, and so on. So you can feel free to download this PCAP. It's like 10 megabytes big. Open it in Wireshark and get used to your Wiresharking through all these protocols if you need some protocol samples for all of this stuff.
Excellent. Yeah, that's really great. And it goes along with some talks you've given at SharkFest. That's a great contribution. Thank you, Johannes, for being on the IPv6 Buzz podcast. We really appreciate you joining us.
Thanks for listening to IPv6 Buzz, a podcast devoted to truth, justice, and 128 bits of address space. IPv6.